The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Let me get my pointer here at acceleration. Wonderful. So first define uniform motion, then acceleration. Uniform motion is motion in a straight line at constant speed. Acceleration is change in velocity per unit time, as we see here. Now, let me give you a scenario here quickly. What ends up occurring, let's just say you're traveling along a road and you're traveling at a constant speed. If you increase your speed, that's going to be a change in your magnitude. Thus, that'll be a change in your velocity, which gives you acceleration. Now, if you're traveling straight at a constant speed and you just change lanes, right? And you go into either the left or the right lane, depending on where you are on the road, that again is a change in velocity, and that's because recall we just said velocity is a vector, right? So with vectors you have direction and you have magnitude, thus you would be accelerating then in the direction towards you would change the lane. So just keep that in mind. And the units for acceleration are meters per second square, and they're that way because the units for change in velocity is meters per second and for time is second. Okay, great. Let's actually do a quick example of this. Okay, example acceleration. What is where are we? There we go. What is the acceleration of the soccer ball when its velocity changes in 1.5 seconds as soccer player A passes the soccer ball with a velocity of 5 meters per second west to soccer player B, who passes the soccer ball back with a velocity of 4 meters per second east? Sometimes you're going to come across these problems. They're really wordy. Just take your time with them and you'll get through them very, very quick. They're very, very simple. Okay, great. In this scenario, first let's write down our equation here. We know that we're being asked for acceleration, right? Which is just going to be a change in velocity. Let me write that a little neater. Which is going to be a change in velocity, right? Now, because this is a vector problem, right? Because it's a vector problem, we have to take care of the direction and we have to take care of the magnitude. And we'll use a Cartesian coordinate system where we'll make our velocity of 5 meters per second west negative and 4 meters per second east positive. Okay, so what is this problem telling us? That in the time of 1.5 seconds, right, soccer player A, right, is going to be passes the soccer ball with a velocity of 5 meters per second, right, west, right, to soccer player B, who then passes the soccer ball with a velocity of 4 meters per second east, right, to soccer player A. Wonderful. In this, now that we have all our values, we can just go ahead and plug them in. So we're going to have 4 meters per second, right, minus 5 meters per second west, right, over 1.5 seconds. This is going to give us an answer of 6 meters per second square acceleration. And because it's positive, right, it's going to be in the east direction. In east direction. That is your acceleration there.